Hello YouTube, and welcome back. This is a Sage screencast about graphing hyperbolas in standard form. And so if you want to see the steps of how to complete the square and go from general form to standard form, you take a look at your TI-84 screencast. This is a redo. We did this one yesterday, but I didn't like how it came out, so I'm just redoing it. And here we go. So, one question we did in class looked like this. Okay, so question 19 from the homework page, 672 last night, was graph x squared over 25 minus y squared over 9 equal to 1. So this is already in standard hyperbolic form. Here's an example that's in general conic form. Ax squared plus bx, y plus c, y squared plus dx plus e, y plus f equals 0. We'll get to that. We're not doing the completing the square stuff now. That look at the TI-84 screencast for that. We're just going to confirm that our graphs looked correct, okay? So what is this? This is a hyperbola because there's a minus in between. If it was plus, it would be an ellipse or a circle. It's a circle if the a squared and the b squared are equal. A squared is 25, so a is 5. B squared is 9, so b is 3. And the x minus h squared makes h 0, and y minus k squared makes k 0. So the center, if this was a circle, would be at 0, 0. And you go 5 to the left, 5 to the right, and up 3, down 3. But that's if you're drawing the ellipse, if it said plus. If it says minus, we box the ellipse. Then we drew lines through the diagonals, through the corners of the rectangle you get when you box the ellipse, and then the asymptotes help you draw the hyperbola. Now remember how the hyperbola works. If it's x squared stuff minus y squared stuff, it opens left and right. Not like a parabola left or right. And if it's y squared stuff minus x squared stuff, the automatic switch is subtracting is not commutative. It'll open up and down, 2 branches. In other words, it's not a function. All right, so how do you graph that? Well, on here, we're just going to solve for y and graph what it tells me. Okay, so first of all, let me just show the equation, make sure I got the right equation. And notice I did a var y, so that we could use y as an algebraic variable. And so now, let's do this. How about we do a print solve that for y. Now, why do I use a print and not a show? Because print gives you ASCII output, which you can cut and paste directly into the plot command so you don't make mistakes copying over by hand, right? And we're going to solve this for y, and let's see what we get. Whoops, I didn't close the print, sorry. I thought I did. And boom. And so we're going to be graphing that. Okay, so let's do a show plot. Show plot. Now we're doing 2 things, right? We're doing this and this, both. So I'm going to need a square bracket for a list of more than one function to graph, and this will be, this one's opening left and right, so this will be the top half is a function, and then or this will be the bottom half, and that will be the top half. Each of those are functions separately, so we're okay. So this part is the same as that part, except for the negative, and I don't need this comment in the square bracket. Get rid of the negative. And if you just graph that, let's see what you get. Closing the plot, closing the show, and evaluate. And you don't see nothing, because remember we said it's like an ellipse that's centered at 0, 0. Or that you go left 5, right 5, up 3, down 3, and you're opening left and right outside the domain -5 to 5. So you're not graphing within -5 to 5. For x is less than 5, or -5 is less than x is less than positive 5, you're not graphing anything. That's not part of the domain. So let's make this domain a little bit bigger. How about from -10 to 10? Okay, so from -10 to 10. Wait, what happened to my 10? Whoops. Let's see what that looks like. And what happened? What did I do? -10 to 10. What happened to the negative? And there it is, pretty much. But if you want to avoid this domain warning, this is a domain warning. It's, in other words, it's saying you're trying to make a graph from -5 to 5, but there's nothing to graph there, right? If you want to avoid that, how are we going to do that? Well, how about we just graph from 5 to infinity? Well, I'm not going to do that. How about from 5 to 10? All right, let's see. So from 5 to 10. Graph that. There you go. But the aspect ratio is really off, right? Isn't it? All right, well, we can clean up the aspect ratio later. Or from negative infinity to negative 5, how about, let's make it negative 10 to negative 5. So we get both the left branch and the right branch if we want, right? Notice no errors. So how do we do this all in one graph if we want? What I could do is, I'm going to do this twice, okay? Let's do this twice. But don't show it. Store it. Let's store it as, I don't know, plot A and plot B. And this is going to be from negative infinity to negative 5, and this will be from positive 5 to positive infinity, technically, but let's stop at 10, because we can't really do infinity, right? Whoops. All right, that'll be, whoops, B equals. And then we can show A concatenated with B, right? Remember, we've done this before. And evaluate that. What do I do? What line? Line 6? Oh, we got it. That I don't need that anymore because I got rid of the show. So get rid of that. Get rid of that. Okay. And there it is. There's both of them. Right. Perfect. Nice. I like it. The aspect ratio may be a little off. If you don't like that, okay. What you could do is put aspect ratio equal to 1 here. Aspect ratio equal to 1 here. But aspect ratio is a parameter for show. So why don't we kill two birds with one stone? Just put it here. You can do that. If you want to see what it looks like for real, but the graph was fine. And there is. So no domain issues, no aspect ratio issues. That's what the hyperbola looks like. So it's like you had an ellipse that went negative 5 to 5 from 0, 0, and up 3, down 3. You boxed it, you connected the diagonals, you drew the diagonals, and that was the asymptotes, and you drew from this side of the box. Right? So this is basically tangential to the ellipse that you're imagining, right? And so is this. So tangential to the ellipse, and then get it closer and closer and closer and closer to an asymptote that way and that way. So notice the green part, that's a function. The blue part, that's a function. But really graphing both as in one, that's one hyperbola, is all of this stuff that's not a function. But there you go. All right, so let's do the same thing for question 50 from the homework. So that's nice. I like that. If you want to put pretty print back on here, that'd be fine, I guess. Let's put pretty print here. Let's do a show and graph that. And that's what we're graphing, right? So this is the bottom branch, the blue stuff. This is the upper branch, the green stuff. And you could do this on your TI-84 also, if you wanted to. You could easily solve this by hand, get Y alone, algebraically, right? You don't need Sage for that. But all right, let's see. How about this one? Now let's show this equation now. That's what we're going to graph now. So now this one is given in general conic form. Can we get it into standard hyperbolic form? We did that in class by completing the square. Take a look at the TI-84 screencast for that. Here I'm just going to solve for Y with Sage and graph what it tells me. Okay, so let's do it. So let's do the same exact steps. Show, solve. Well, actually, this was the print solve, right? Print, solve, that. For Y. And let's close the solve, let's close the print, and let's see what we're going to be graphing. So what are we graphing? We're graphing this stuff. So let's copy this and put that into a plot. Now this one's opening up and down because it's y squared minus x squared. So the upper branch is a function by itself, the bottom branch is a function by itself. There's no domain issues. It's not doing left and right. So we're not going to worry about this domain issue stuff. We don't need the plot A, plot B stuff. All right, so we're just going to graph these as a list, a square brackets, a list, two of these, right? And notice these two are the same except for the minus in front of the half, right? Okay, so copy this, and let's do a show plot. Okay, whoops, plot. And you need a square bracket to list the two branches, the upper branch, well, that's the bottom branch. And then this will be the upper branch if you get rid of the minus. And now I don't need the comma, so square bracket. And, well, I don't know how big a window I need. All right, let's leave it like that for the moment. Let's close the plot, let's close the show and see what it looks like. All right, so it looks like the center of the ellipse that we blew up in class was out here somewhere, like maybe 1, -2 out here. So instead of -1 to 1, how about -1 to 2, I guess? Or -2 to 3, something like that. So a few units to the left of the center, a few units to the right, 2 units, all right? So -2 to 3. How about that? So let's do that. Let's make this a little bigger so you can see what I'm doing. Not that big. So let's go from -2 to 3, comma, -2 is the x-min, +3 is the x-max. All right, so because it's centered at x is 1, right? Is that what we said? Yeah, x is 1, so go 2 to the left is -1, and 2 to the right is +3. Whoops, -1. Okay. Just to make it symmetrical. You don't have to, but it'll look nice. And boom, here it is. Okay, so there's the parabola, the hyperbola. There's the top branch, and there's the bottom branch. Each one separately is a function, but together, this is not a function, doesn't pass the vertical line. That is the hyperbola. Is the aspect ratio okay? It's not bad. I think that's not bad. Leave it. Right? If you want more, you could get crazy and go, all right, get a little crazy. How about go 2 farther to the left, -3, and 2 farther to the right, +5. And what about the aspect ratio? Okay, aspect ratio equal to 1. How about that? That's what that looks like. All right, so question 50, graph side is this hyperbola. There it is. It's nice. Done. Perfect. And unless you want to do a show here instead of a print, but there you go. Done. So it's centered. The center would be 1, -2 if you did the completing the square thing. And you're opening up and down. So there you go. Okay, good. And, all right, so just put a show here just for fun. So for question 50, the bottom branch, the blue stuff is this, and the green stuff is this. There it is. The green stuff is this, and the blue stuff is this. And you could also have done this by using a quadratic formula, solving this as a quadratic in y by hand, and then putting this into your calculator. Get this, put this in your calculator. This looks like a quadratic formula output, right? Doesn't it? Where A is 2, B is 8, and C is everything else. You could do that. Using quadratic formula, you get y alone here, algebraically. If you're not completing the square, you're just checking on your calculator, but here we go. And so we're done. So there's all the code, and there's all the graphs, and we're done. Okay, I hope that was helpful. YouTube, bye-bye.